How streaming services work. Not very long ago, watching a movie at home usually meant waiting for something to download or driving to a store to rent a physical disc. Today the process is much simpler. You open an app, click on a show, and within seconds the video starts playing. Platforms like Netflix, YouTube, Disney+, and many others make this feel effortless. But behind that simple play button is a complex system designed to move enormous amounts of video data across the internet. Video files are large, internet connections vary in speed, and millions of people may be watching at the same time. Yet somehow the video starts quickly and usually plays smoothly. So today we are going to walk through how streaming services actually work and how they deliver video across the internet in real time. Chapter 1. What streaming actually means. Streaming simply means playing media while it is being delivered over the internet. Instead of downloading the entire video file first, your device receives small pieces of the file continuously. As those pieces arrive, your device begins playing the video immediately. More pieces continue arriving while the video is playing. This allows viewers to start watching almost instantly rather than waiting for a full download. In other words, the video is being transferred and played at the same time. Chapter 2. Breaking video into small pieces. Video files can be extremely large. A full-length movie might contain several gigabytes of data. Sending that entire file at once would be slow and inefficient. Streaming services solve this by breaking videos into many small segments. Each segment may represent only a few seconds of video. When you press play, your device begins requesting these segments one by one. As soon as the first few segments arrive, playback can begin while the rest continue downloading in the background. This segmented delivery makes streaming far more flexible and efficient. Chapter 3. Video compression. Another important part of streaming is compression. Raw video files are enormous because they contain detailed image information for every frame. Compression algorithms reduce the size of the video file while trying to preserve visual quality. They do this by removing redundant information and storing only the changes between frames. For example, if most of the image stays the same between frames, only the differences need to be stored. This dramatically reduces the amount of data required to transmit video. Without compression, streaming services would require much faster internet connections than most people have today. Chapter 4. Adaptive streaming. Internet speeds vary from person to person and even from moment to moment. Streaming services account for this using something called adaptive bitrate streaming. Multiple versions of the same video are stored at different quality levels. One version may be very high resolution while another is lower resolution. Your device constantly measures your internet speed while the video is playing. If the connection slows down, the system temporarily switches to a lower quality version of the video. If the connection improves, it switches back to higher quality. This adjustment happens automatically and usually without the viewer noticing. Chapter 5. Buffering. You may have heard the term buffering when a video pauses briefly before continuing. Buffering occurs when the device needs to download more video segments before playback can continue smoothly. Most streaming apps maintain a small buffer of upcoming video segments stored temporarily on your device. This buffer allows playback to continue even if the connection briefly slows down. If the buffer runs out before new segments arrive, the video pauses until enough data is downloaded. While buffering can be frustrating, it helps prevent constant interruptions during playback. Chapter 6. Content delivery networks. Streaming services must deliver video to viewers all over the world. If every request came from a single central server, the system would quickly become overloaded. To solve this problem, streaming companies use something called a content delivery network, or CDN. A CDN consists of many servers distributed across different geographic regions. Copies of popular videos are stored on these servers. When you press play, the system connects you to a nearby server rather than one far away. This reduces the distance data must travel and helps videos load faster. Chapter 7: Handling millions of viewers. Large streaming platforms may have millions of viewers watching simultaneously. To handle this demand, the system must be able to scale efficiently. Cloud infrastructure allows streaming companies to add more servers when demand increases. Popular content may also be cached across many servers in the delivery network. This ensures that large numbers of viewers can access the same content without overwhelming a single server. Chapter 8: Streaming devices and apps. Streaming services also rely on software running on your device. This could be a smart television, phone, tablet, computer, or streaming box. The app on your device handles tasks such as requesting video segments, managing the buffer, adjusting video quality, and decoding the compressed video data. Once decoded, the video is displayed frame by frame on your screen while audio is played through your speakers. All of this happens continuously while the video is playing. Chapter 9: Recommendations and personalization. Beyond delivering video, streaming services also try to help viewers find something to watch. Many platforms use recommendation systems powered by machine learning. These systems analyze viewing habits, ratings, and other patterns. Based on that information, they suggest movies or shows that you might enjoy. While these systems do not always guess perfectly, they help organize enormous libraries of content into something manageable. To wrap up, streaming services deliver video by sending small segments of compressed data over the internet while the video plays. Instead of downloading the entire file first, the device receives pieces continuously. Adaptive streaming adjusts video quality based on connection speed, while buffering helps prevent interruptions. Content delivery networks store copies of videos across many servers around the world to reduce delays and handle large numbers of viewers. Together, these technologies allow millions of people to watch video instantly across many different devices. Streaming services make watching movies and shows feel simple. But behind that simplicity is a sophisticated system designed to deliver massive amounts of video data quickly and reliably. By combining compression, adaptive streaming, distributed servers, and smart software, these platforms make it possible to watch almost anything with just a single click. This has been a mini Leviathan production. If you enjoyed it, check out our other videos. Comment below what other topics you would like us to cover. See you in the next one.